Now again, if this is a college level course, which means it's a little bit fast and furious, we have seen probably all but one of the things I'm going to show you. And the one thing I'm going to show you that you've not seen before, you might have seen it for like one example and then moved on. But in this class, we're going to need to know how to do it. So a lot of your practice problems will require you to complete the square, and we'll go slower over that than the rest of the things here. So you can turn it in early if you're done, yeah. So today we're working on solving quadratic equations. We know that quadratic equations look like this. A squared plus b, what am I saying? Ax squared plus bx plus c equal to 0, where a, b, and c are real numbers. A quadratic function, on the other hand, is the same vibe, except that it's not equal to 0, it's equal to f of x. We'll be dealing with functions really in the next chapter, but today we're working with the equations. When we're looking for the zeros of a function, the zeros are also known as the solutions. So we know we can always go check our work by graphing this function and looking for the graphical zeros or the x-intercepts. But we are going to need to know how to do all of this by hand because I'm going to require you to show your work. Like I said, we're going to learn like 4 ways, I guess I should say review 4 ways to solve a quadratic. Some of them work in different ways. Like there are some that cannot be solved by factoring and some that can. But we're going to get ourselves really well used to the different ways to solve a quadratic. The first way we're going to solve is to solve by factoring. Now, factoring is everybody's favorite. If you forgot immediately what factoring is, that's when we take a quadratic and we write it in factored form with the parentheses. Once we have them in parentheses, this blue theorem called the principle of zero products allows us to set each parentheses equal to 0 and solve what is typically a 1 to 2 step tiny little equation and make it much, much simpler. When you're factoring, it is necessary that you rewrite the question or the equation so that it says equals 0. There's going to be times when it doesn't say equals 0. Don't start factoring until your equation says equals 0. Then you're going to factor completely and you're like, well, there's where there's a lot of things happening in that one little step. I agree. You're always going to start this step by checking for a GCF and factoring that out. That may be all you have to do. After that, then you get to choose the way that you factor. Okay, after the GCF, I like the guess and check method. If you don't know the guess and check method, you can use the X puzzle method. If you don't know those and you know grouping, we'll get to grouping. There's going to be a whole lots of ways to factor. Again, I like the guess and check method because it is an X puzzle in your brain. It saves paper. I will always show the guess and check method, but if you need the scaffold of an X puzzle, that's fine. Love it. Great. Awesome. Then after it's factored, you'll apply the zero product principle, setting each factor equal to 0, solve the tiny little equations, and as always, you can check your work in the original equation. So let's just start. Let's solve this quadratic by factoring. Always check for a GCF first. Do those 2 terms have anything in common? And what else? 2 and x. So factoring is basically like reverse distribution, which means it's division, okay? Pretty much what we're doing is we're taking 2x and we're dividing it out of each of these terms. That's taking out the GCF. Well, 4x squared divided by 2x is just 2x, and 2x divided by 2x is -1. Is there any way I should or need to make that stuff in the parentheses smaller? It's about as small as it can get, right? There's no other squared term, so I'm done factoring. The zero product property means that I can take the first factor, which is this bit right here, and set the first factor equal to 0. Boom. I can take the second factor in parentheses here and set that factor equal to 0. And I can solve each of those individual tiny little equations to find the solutions. In that first equation, I divide by 2 on both sides, which means x is equal to 0. On the other one, I add 1 to both sides, and then I divide by 2 on both sides, and I get that x is equal to 1/2. Since these are both x equals 2, we've solved an equation. You can plug them back in to check your work. We're going to skip that step just within our notes, but you can always do that on a quiz or test or something. Questions, comments, concerns? Okay, cool. That's a GCF. All we needed on that one was to factor out the GCF, and we were in fully factored form. In number B, though, we're not going to have a GCF. In fact, it's not even written in standard form because right now, what is it equal to? And what should it be equal to? Great, so I'm gonna just take that 4 and I'm gonna move it to the other side. Subtract 4 from both sides basically, so that it is now equal to 0. That's good, we want that. Now the guess and check method, I'm gonna show a lot of work for it, but we should do this in our head. To set up the guess and check factoring method, you start by making 2 factors. This might be something you like write steps for yourself if you don't know this. You're gonna fill the first set of parentheses with 2x and the second set of parentheses with a regular x. Where do we think I got the 2x from? From right here. If there is a number in front of x, you put it in the first parentheses only, not the second. If there's no number in front of x, then they're just both regular x's. Then we think to ourselves, all right, what are the things that multiply to make 4? 2 and 2, 4 and 1. So we start to guess and check. Let's just start at the beginning of 1 and 4. If I try this in my head, we know we're trying to combine these things in some way to make 7. Here's 2 times 4, and here's 1 times 1. Is there a way to make 2 times 4 and 1 times 1 equal to 7? If one of them, which one is the negative? The 1, because we want 8 minus 1 to make 7, right? So that means the one that went across the top, this guy right here that I just erased, he's going to have to be positive. And the one on the bottom that I just erased is going to have to be negative. If that hadn't worked, if we had done 4 and 1 or 2 and 2, when we did that little distribution step to see what it would create in the center, we wouldn't get negative 7. This is the same thing you're doing if you solved an X puzzle. So if you know how to solve an X puzzle to factor, same thing. It's just in one step, less paper. But look, it's in fully factored form. So we set each of the little factors, 2x minus 1 equal to 0, and x plus 4 equal to 0. To solve the first little mini equation, you add 1 to both sides, and then divide by 2. So 1/2 again. And if you've solved the other one, all we're doing is subtracting 4 from both sides. And that's it. Does it sound like something we've done before? Yes. Okay. Again, if you know much better with the X puzzles, go for it with an X puzzle. Totally fine by me for that to happen. So let's leave factoring. I feel like we've got it. We've factored before. We understand it. Let's go to some of the less popular ways to solve a quadratic. Let's solve it by the square root property. So this principle of square root says that if x squared is equal to k, then if you solve for x by taking the square root, that you need to make sure that you're remembering to use both the positive square root and the negative square root. So let's make a little reminder to ourselves that when we actively take the square root of something to solve, we need to do plus or minus. This is also going to be the method that you use, this by the square root property. You're going to mainly use this one when there are 2 terms in the equation. And not like a GCF, like they don't have a GCF to factor out. This is going to be much easier. So what we're wanting to do is we're wanting to get it to be looking like this right here to use the square root property. So we're trying to isolate the x squared in this equation. For a, to isolate x squared, meaning I'm trying to get the x squared by itself, I'm actually going to move that 15 to the other side. So it's no longer set equal to 0. I'm trying to isolate x squared, which means I want to get rid of the 3 in front of it, divide by 3 on both sides, and voila, I have the x squared isolated. The inverse operation of squaring something is square rooting it. But when I actively take the square root of something, I have to put the plus or minus in front of it. The only thing that can make this more complicated is if that square root of 5 can be broken down and reduced as a radical. Can you break the number 5 down at all? No, so I'm actually done. I can't reduce that radical. So again, for the square root property, we're not setting it equal to 0 necessarily. We're trying to get the x squared by itself, or the squared term at least by itself. Can I make it a little crazier? Same idea, we're trying to get x squared by itself. So what would you say I should do first? Great, move the 25 over. So I have 9x squared equal to negative 25. What next? Divided by 9 first. We got to get the x squared or the squared term all the way by itself. Now 25 and 9 don't divide evenly, so I'm going to leave it looking like that. What's next? Now I square root it. So a bunch of stuff is going to happen at the same time. I go to square root it, which means I remember to put plus or minus, and I'm going to square root the whole thing, which is negative 25 over 9. Now we're not done here because these numbers can be reduced. First of all, your spidey senses should be going off. You got a negative underneath a square root. What did we do with that last class? It became I. So I know immediately I'm going to have plus or minus I and then something. Now this is a fact of radicals most students forget. You can split the radical to top and bottom, meaning the square root of 25/9 is the same as the square root of 25 over the square root of 9. See how I split it to top and bottom? Yeah, so this is just plus or minus 5 over 3 I. Did we follow? Yes, I'm seeing the nodding of heads. I also see a maybe not. Can we think of a question? For this last one, oh, I clipped it in there. That's cute. For this last one, we're not necessarily at first trying to isolate the x squared, because notice there is not actually an x squared. There's an x minus 2 squared. So right now, the squared term is straight up by itself, right? There's nothing else on the same side as the term that is squared. Nothing in front of it, nothing added or subtracted behind it. So I'm already at the moment where I can take the square root of both sides. This square root is going to get rid of the parentheses and the squares on the left-hand side. Now I'm one step away from having x by itself. What do I need to do to get x now all the way by itself? Plus 2. Now that plus 2 is what I'm adding to plus or minus square root 6. That means that it goes in front of the plus or minus and the square root 6. We're not multiplying it, we're adding it to both sides. If we were multiplying, it would go between the plus or minus and the square root because you're multiplying that term, but we're adding 2 to that value. And voila, those are our two solutions. Again, the only way this can get a little bit more tricky at all is if this number right here, the 6, could be broken down into some sort of like 2 square root 2, right? Like you have to break that number down if necessary. Questions about the square root property? Isolate the squared term. Don't forget your plus or minus. And then comes my favorite. I used to honestly hate this method and I'd avoid it like the plague. But now I actually think it's really neat to do completing the square, and there is an actual use for it that we will need later in this class to write the equations of circles. So don't pretend like we're not going to use it. We actually will use it in this class. Completing the square is the way that you probably avoided in Algebra 2. Like I said, you may have seen this for one day and moved on. It may not have even been covered in Algebra 2, so I will slow down here. To complete the square, we're going to need to add this term b divided by 2 squared to both sides of your quadratic to make a perfect square appear on the left-hand side. Okay, b squared divided by 2, it's got a visual here of why that actually works geometrically. But let's just practice identifying what b squared divided by 2 would be. So in example 3, it says, let's just create perfect square trinomials. By completing the square, we're not solving anything. We're just practicing the b squared divided by 2 step. In example A, I want to identify the b term here. Boom. That's the b term. B is always next to the x, chilling by itself. So I'm going to take that number 8. And I'm going to fill it into my b squared divided by 2 formula. So this is going to be 8 divided by 2 squared. Now don't do too much. I actually want you to show each of these steps for a particular reason in a second. What is 8 divided by 2? 4. What is 4 squared? the number I would add to both sides of this quadratic, if I were trying to solve it by completing the square, I would add 16 to both sides. What about b? What is the b term of b? -7. Very good. Okay, so since that sign is negative, that means b is a -7. I'm going to do -7 divided by 2 squared. Okay, -7 divided by 2. Can I reduce that perfectly? No, so I don't have an intermediate step here, but I am going to square. What is -7 squared? 49. What is 2 squared? 4. 49/4 is the number I would add to both sides to make a perfect square. Oh dear, what about C? What's the B term here? Yikes. Okay, we can still do this. We're going to do 3/5 divided by 2, and then we're going to square it. Oh dear, but we need to remember our fraction rules. I believe we've gone over it in this class a little bit, maybe. What's the rule when you're dividing fractions? It's like 3 letters, 3 words. I think you just keep, change, flip. We keep the first fraction. We change the big divide sign into a multiply, and we flip the denominator. Right now, this denominator is 2 over 1, so I flip it to 1/2. Once it's a multiplication, we do top times top, bottom times bottom. In case we forget later, that was keep, change, flip. Which means that now b divided by 2 squared would be 3 over 10 squared, which is what? 9 over 100. Very good. You square the top, you square the bottom. So that's the initial step on completing the square. We're going to add it to both sides, which creates what's called a perfect square trinomial on the left-hand side, which allows us to then go back and solve by square roots. So this process, like I said, you probably didn't necessarily do completing the square all that often, but we're going to do it in this class a lot. I keep saying slowly and I'm going pretty fast, but I will actually slow down on this next part. Is that okay? All right, let's try one. We've got the steps on the back here to solve a quadratic by completing the square. First, and this is important, if a, the leading coefficient, is not 1, you're going to divide by a. So like looking ahead, what is a on this one? We're good. What is a in this one? We would have to divide every single term by 9, and we will do that when we get there. Then we're going to isolate the variable terms on one side of the equation and the constant terms on the other side of the equation. We don't want it to be equal to 0. It needs to be equal to the constant. So we have 2 terms on the left side and the plain number on the right. Then we're going to complete the square, which means we are going to add whatever b divided by 2 squared is on both sides. Once we simplify a bit, we will be able to use the square root property to quickly solve for x. So let's try it. In letter A, I want only the x terms on the left-hand side, which means I only want this term and this term to be on the left side. I want the 4 to move to the other. But when I do this, because I've done this process many, many times, I'm going to leave some blanks, which means I'm going to write it like this. X squared minus 6x plus something is going to be equal to -4 plus that same something. We need to figure out what goes in the box. Do we follow where the 4 came from? I just moved it over. Let's figure out what goes in the box. What goes in the box is b divided by 2 squared. What's the b term here? -6. So if I take the b term and I do -6 divided by 2 squared, what's -6 divided by 2? -3. And then -3 squared is 9. That 9 goes in the box. okay? So if I rewrite this question, I'm going to have x squared minus 6x plus 9 equal to 5. Where'd the 5 come from? Negative 4 plus 9. Okay, great. Now the reason we went about doing this is that I want to be able to perfectly square factor the left side. And this is why I wanted you to show that bit of work. That entire left side is going to immediately factor to a perfect square. That perfect square is x minus 3. Where do you think I got the negative 3 from? That middle part of b divided by 2 squared. That's why I was having you show that work, even though it wouldn't be that too hard to do it in our head. That number, negative 3, whoop, goes into our perfect square. Now this problem looks a lot like the last problem we did when we were solving by the square root property. We have isolated the squared term, so I'm going to take the square root of both sides. It gets rid of the parentheses, and I do the oh, I didn't even write my square root. Square root 5. I'm one step from finishing this. I add 3 to both sides, which goes in front of the plus or minus square root 5. Okay, pause and stare at what we did. I'm assuming we have questions. Please, what are our questions? Where did I lose you? At the very bottom, I added it to both sides. Do we?
I think it was the fraction one, right? Like when I did the negative 6 squared 36 over 4, which got 9 anyway.
Yeah. So if you do, yeah, b squared divided by 2 divided by 4. Yeah, that always will work. But if you do it this way, the number inside this parentheses here is exactly what goes here. So if you see this number here, it's like faster to do the perfect square part, showing this work this way. Does that make sense?
Yeah, because and then I got the quadratic equation, and then it just like knew it was the x minus 3 next one.
Can we do one that's a little bit more challenging, or do we need a second on this one still? Okay, let's try it. Now, you guys already told me when we were reading the instructions at the top that we're going to have to do something to this equation before we start to complete the square. What is it? Divide by 9. So I'm going to divide every term by 9, which makes x squared minus 6 over 9x minus 4 over 9 equal to 0. Now, that middle term, 6 over 9, that reduces as a fraction. What does that reduce to? So I'm actually just going to write it as 2/3 to save myself space. So I erased it and put 2/3. Okay, we're ready to start. But we are going to move the constant term to the other side and put boxes. Really? We're going to put a box where it needs to go. So this is x squared minus 2/3 x plus something equal to positive 4/9 plus something. Where'd the positive 4/9 come from? Yeah, I took the negative 4/9 from the left side and I moved it to the right. Now I have my blanks that I'm ready to put the b divided by 2 squared into. So let's figure out what that number would be. We have b is negative 2/3. We're going to divide that by 2. And then we're going to have to square it. Now negative 2/3 divided by 2. What is that? You would have to keep change flip because it's 2 over 1. What do we get, y'all? When you keep change flip that. Negative 2 over 6, which does reduce. What does negative 2 over 6 reduce to? Negative 1/3. All right, so negative 1/3 is my number inside here. Now I'm going to square it. Negative 1 squared is 1. 3 squared is 9. Again, this 1/9 is the number that's going to go into the boxes on both sides. So my equation would read x squared minus 2/3 x plus 1/9 equal to 5/9. Again, where'd the 5/9 come from?
When you add them.
Yeah, 4/9 and 1/9 make 5/9. Okay, the left side is where we focus, and it looks absolutely crazy right now. But remember, we have the number that makes this perfect square. We have it in the center of our work. This becomes 1 minus 1/3 squared equal to 5/9. Where'd the 1/3 come from again? Yeah, right here. That's why I like to show that work, because I can see it in the center. Okay, we're just a couple steps away from being done. We're going to square root both sides because I want to get rid of those parentheses that are squared. This becomes x minus 1/3 equal to plus or minus the square root of 5 over 3. I did 2 steps at once. Can anybody tell me what I did?
You got rid of the square.
Mm-hmm.
To the other side, and then
Where'd the 3 come from? Yeah, what's the square root of 9? 3. So when you square root a fraction, remember you can square root the top and square root the bottom separately. Can you take the square root of 5? No. So I just left it as square root of 5. But the square root of 9 is 3. One more step, what is it? Move the 1/3 over. So this becomes x equal to 1/3 plus or minus square root of 5 over 3. And voila, we have solved it by completing the square. So for us right now, I feel like we need to stop because I want you to practice a couple completing the squares before I let you go. We're going to finish this section first next class. Instead of moving directly on, we're still going to cover the next section next class. But I feel like we need a little bit more time to let this one simmer. So we're going to pick up next class at the quadratic formula on these notes and finish out with the discriminant there. But before we go, we've got like 15 minutes. I want you to skip to, on your homework, I want you to skip to the section that has the completing the squares and start with those questions because I feel like we need to address the issues we're going to have with completing the square before we leave. Okay? So you don't have to do your homework in order as long as you do all the problems, especially today because I'm telling you to start with the completing the square problems. We will come back to the rest of these notes next class. Oop, I left this on.